So ठीक है, let's start with this paper. आयजा, आवाज आ रही है?
जी सर।
अच्छा, so starting with ये winter 2019 QP23 है, ठीक है? So starting with the first question. Okay, explain why MnO2 is described as, ठीक है? So the first one is, so side पे कर लें, MnO2 is being described as an oxidizing agent. तो मुझे बताओ कि इसकी what is the oxidation state of Mn over here and what's the oxidation state of Mn over here?
+4 and
ठीक है, over here it's +4, over here it's +2. So that's so it's getting reduced. ठीक है, it gets reduced and it gains electrons. I said gains electrons. State what you would observe during this reaction. So what's the observation? What's the observation when Cl2 is formed?
effervescence.
Green.
The greenish yellow gas.
So it could be right effervescence.
Effervescence, check कर लेता हूँ. I have the marking scheme with you. It's probably not going to be acceptable क्योंकि chlorine is kind of very stable.
सर कौन सा पेपर था?
W1923 है. ठीक है, इसका let's have a look. नहीं किया हुआ है, effervescence accept किया हुआ है, ठीक है. Green gas भी किया हुआ है. ठीक है, I wasn't going for effervescence because वो डिपेंड करता है कि वो बबल्स कितनी तेजी से प्रोड्यूस हो रहे हैं. We didn't know. जैसा कैल्शियम कार्बोनेट में तो बहुत तेजी से बबल्स प्रोड्यूस होते हैं ना. Cl2 is kind of soluble. तो अगर बहुत स्लो रिएक्शन है तो वो फिर, लेकिन खैर एक्सेप्ट किया हुआ है. State explain the trend in volatility. You have to explain, पहले तो state the trend. What's the trend? Volatility increases or decreases down the graph?
Decreases.
ठीक है. Okay, so it decreases down the graph. Why?
Because the atom gets bigger and the more van der Waals force.
ठीक है, so more electrons and you have more van der Waals forces. For example, in I2 molecule, they would attract each other very strongly compared to an F2 molecule because there would be more temporary dipole induced dipoles. As the next one, chlorine undergoes disproportionation during many chemical reactions. Write an equation for the reaction of chlorine with cold aqueous NaOH. Explain why it is disproportionate. पहले तो you have to remember this equation. ठीक है, that's given in the notes. क्या होता है reaction? Cold के साथ.
NaCl plus NaClO plus water.
ठीक है, so there is NaCl plus NaClO plus water and it is balanced. सारा 1-1 होता है. ठीक है. Why is it disproportionation? What is disproportionation?
So same amount reduce हो रहा था और oxidize हो रहा था.
अच्छा, so same element gets reduced in oxide. Cl gets reduced. कहाँ पे? यहाँ पे NaCl में. ठीक है, with its -1 and oxidized at the same time. NaClO में it's +1. यहाँ पे it's +1. Over here it's -1. So Cl gets reduced and oxidized, so which is why it's disproportionate. One of the products of the reaction of chlorine with hot aqueous NaOH differs from that in C1. Identify the compound that is formed in this reaction that is different. The hot NaOH में what is different than this equation?
NaClO3.
ठीक है, तो NaClO form नहीं होता, NaClO3 form होता है, which is sodium chlorate 5. This one is known as bleach. ठीक है, वो bleach होता है जो कपड़ों का bleach होता है. NaClO3 on the other hand is sodium chlorate 5. ठीक है, जहाँ पे Cl is +5. but that happens in hot. Acha, State, explain the use of chlorine in water purification. What does it do?
Kills
So
bacteria.
destroys bacteria.
ठीक है, so it's a disinfectant, kills bacteria. What's the reaction when you add Cl2 to water?
HCl and HCl.
ठीक है, HCl and HClO is produced. ठीक है, let me just check what's the second mark given for HClO form होने का. ठीक है, we wrote that. The first one was for kills bacteria. So then you have state the conditions required to. This is free radical substitution of ethane. What's the conditions required for this? What happens in free radical substitution? Step
UV
one.
light.
ठीक है, UV light, and because of UV light, homolytic fission happens, and that results in the formation of Cl radicals.
So homo और heterolytic में क्या फर्क है?
होमोलिटिक में इक्वल होता है कि एक इलेक्ट्रॉन इसके पास किया है तो एक इलेक्ट्रॉन इसके पास किया है. ठीक है, the electrons get distributed equally. In heterolytic fission, for example, if you have an HCl molecule and it ionizes in water, so अच्छा, तो उसके अंदर what happens is कि both electrons they go towards one atom, and that results in the formation of Cl-1 and H.
So वो जो ब्रोमीन में होता है जब हम कर रहे होते हैं एल्कीन के साथ
हाँ,
propionation
वो
में.
मतलब फ्री रेडिकल सिर्फ इसमें है. ठीक है, होमोलिटिक फिशन में मतलब द ओनली वन अल्केन्स की जो फ्री रेडिकल सब्स्टिट्यूशन है ना, इसके अंदर दिस इज द ओनली प्लेस वेयर यू हैव दिस हैपनिंग. ठीक है,
ठीक है जी.
अच्छा जस्ट वन सेकंड, लेट मी एक मैसेज कर लो.
Sir, are you uploading these lectures on YouTube?
कौन से? हाँ,
ये वाले, ये जो लाइव चल रहा है, ये आप अपलोड करते हैं?
हाँ ये मैं करता हूँ, मैं सारे नहीं करता जितने हो जाए. अच्छा, next one. अच्छा, overall equation for the free radical substitution reaction. What's the overall equation? What happens? इसको तो हम हटा देते हैं कि we can इसको साइड पे करो. अच्छा, what happens in free radical substitution? Once the free radical is produced, what does it do? कि अगर there's an alkane like ethane, so what would it do to ethane?
So H ले लेगा.
ठीक है, so it's going to take away the H, and that would result in the formation of HCl, and that would result in the formation of an ethyl radical क्योंकि उसके पास फिर एक बॉन्ड कम हो जाएगा. ठीक है, और उसकी भी होमोलिटिक फिशन होगी. और फिर ये चलता रहेगा कि the ethyl radical would try to complete its bond, तो it would वो क्लोरीन के मॉलिक्यूल में से एक क्लोरीन अपने साथ अटैच कर लेगा, तो क्लोरीन का रेडिकल जो है वो दोबारा से फॉर्म हो जाएगा. ठीक है, सो इट्स जस्ट गोइंग टू कीप ऑन कंटिन्यूइंग दिस वे. इस स्टेप को क्या कहते हैं? व्हाट इज दिस द नेम ऑफ दिस स्टेप?
Propagation.
ठीक है, सो दिस इज प्रोपेगेशन कि वो Cl आके अटैच हो जाएगा एंड द Cl रेडिकल is again reformed, and this keeps on happening. ठीक है, बारी बारी the H is getting substituted by Cl, and the last step is at any point termination could happen. Any of the two radicals might simply join up. So they might simply join up, and if they join up, तो रिएक्शन वही खत्म हो जाएगा. इसको एक बॉन्ड चाहिए, Cl को एक बॉन्ड चाहिए, so they might just simply join up to form or terminate the reaction. ठीक है, they would link up. So write the overall reaction. The overall reaction is the one that you wrote in O levels. You have C2H6, and it would become C2H5Cl. Now it's up to you. जितने मर्जी Cl substitute करो, that's up to you, and HCl molecule is produced as a byproduct. Because that's That's what the overall reaction is. ठीक है. Uh, इतनी space क्यों दी हुई है? How many marks was this? I said just 1 mark. I said then you have type bonding, sodium oxide. What's the type of bonding that happens in sodium oxide?
Ionic.
ठीक है, that one is ionic. What about MgO?
Ionic.
Aluminum oxide.
Partial ionic and covalent.
No, aluminum oxide is ionic. Remember, the exception is aluminum chloride. That is covalent. ठीक है. Oxygen is highly electronegative. ठीक है. So oxygen के साथ it's not going to share electrons. Oxygen उससे electrons छीन लेगा. Silicon oxide is covalent. ये भी covalent है. Structure. What is structure? Giant है कि simple है?
Giant.
Hmm?
Giant होगा. Giant structure.
ठीक है. So it's going to be giant. Ionic is always a giant structure. This one is also a giant structure. Then you have aluminum oxide, ionic, जितने भी हैं वो giant structures हैं. ये भी giant है, silicon oxide. The last one is a simple molecular structure. Okay, just let me check quickly कि structure के अंदर खाली giant वगैरह चल जाएगा कि नहीं? Where's the ठीक है, बस वही है, simple molecular और giant macromolecular. I said next one, explain why the boiling point of SiO2 is much higher than SO3. Why is SiO2 having
Giant and simple, then a lot of covalent bonds.
ठीक है, so in this case, large amounts of energy is needed to break a lot of covalent bonds because it's a giant covalent structure. ठीक है, that's needed to break many covalent bonds. Because it's a giant covalent structure. अच्छा, what about SO3? SO3 में क्या break कर रहे होगे?
It is a simple molecule.
ठीक है, SO3 के अंदर SO3 is a simple molecular structure जो कि ऊपर भी लिखा हुआ है. तो उसके अंदर जब आप उसको मेल्ट या बॉईल कर रहे हो तो what are you actually breaking?
Intermolecular.
Intermolecular forces, and in this case SO3 is a non-polar molecule क्योंकि it's fan shaped, the dipoles cancel out, so उसके पास सिर्फ van der Waals forces होती हैं. So you have to break weak intermolecular forces, or ज़्यादा specific भी हो सकता है, you're basically breaking weak van der Waals forces. You don't have to break any bonds, so less energy is needed. For that. That's the next one. Al2O3 is an amphoteric oxide. Explain what is meant by the term amphoteric and use equations. तो ये वही notes में देखने के क्या क्या equations थी. Amphoteric. What's amphoteric?
So it's substance which act as a base and an acid, both.
So it reacts with both acids and bases. ठीक है? And you have to write the equations of Al2O3 with both an acid के साथ लिख दो. क्यों उससे क्या chemical equations लिखो. ठीक है? So one is with an acid, the other one is you can write it with NaOH. ठीक है? दोनों के साथ कर लो. तो first में क्या बनेगा? What's the salt that's going to be produced?
AlCl.
ठीक है, that's going to be AlCl3 plus water. दूसरे में क्या बनेगा?
AlNaO.
LOH और
नहीं, NaLO2. ठीक है. सोडियम एल्यूमिनेट बनता है, जैसे ये बॉक्साइड का रिएक्शन होता था ओ लेवल्स में, उसके अंदर भी यू हैड टू रिमेम्बर दिस, ठीक है। वो बॉक्साइड डिसॉल्व होता था NaOH में, इट वाज सोडियम एल्यूमिनेट, ठीक है, विद H2O। तो it's sodium aluminate. State what you would observe when a small sample of sodium oxide is placed in water. What would you observe?
Hydrogen.
White.
Why? नहीं, इसको पानी में ऐड किया क्या होगा? पहले तो बता
So
प्रोडक्ट क्या बनेगा?
white flame. नहीं.
This place नहीं, पानी में डाल है सोडियम,
Hydrogen.
पहले बता सोडियम ऑक्साइड is soluble or not?
Yes, yes.
Soluble.
So it's going to form NaOH, ठीक है। कोई भी ऑक्साइड जो होता है ना, that's soluble, it would form a even insoluble oxides, अगर वाटर बहुत ज्यादा हो तो वो हाइड्रोक्साइड्स में कन्वर्ट हो जाते हैं, and it's very soluble, तो बस solid dissolve होगा, that's it।
So observe है तो हम flame का नहीं लिखेंगे।
नहीं, फ्लेम बनेगी नहीं, फ्लेम तो फ्लेम होता है ना। सोडियम ऑक्साइड जो है दैट्स ये इसका क्वेश्चन है कि इफ यू हैव एन NaCl सॉल्ट, उसको पानी में डालोगे, व्हाट वुड हैपन? तो इट वुड सिंपली डिसॉल्व, ठीक है। फ्लेम टेस्ट एक अलग चीज है, फ्लेम टेस्ट आप अलग से करते हो कि आप एक वायर लेते हो, उसके ऊपर आप सोडियम आयंस वगैरह या उसकी कोई सॉल्ट को फिर फ्लेम के अंदर डालते हो, यू सी कलर्स, ठीक है। तो वो तो आप एक अलग अलग से फ्लेम टेस्ट करते हो। In this case, there wouldn't be any flame; it would simply dissolve. And let me just confirm this: it's going to, as we dissolve, disappear. एक वो लिखा हुआ, it becomes hot, ठीक है। That's another observation that is accepted. अच्छा, ये मैं फिर से बता दूं कि this one, ये किसी क्वेश्चन आया हुआ था, this one over here, कि oxide and hydroxide, it's going to be pretty much the same thing, ठीक है। Oxides and hydroxides are interchangeably used. You can call it NaOH4 as well, ठीक है, which is going to be the same thing, ठीक है। Hydroxides, NaOH, Na2O, they're kind of pretty much the same thing. It's only water getting added, water getting removed. That's it. So next one is this selenium is a group 16 element which shows similar chemical properties to sulfur. So he's basically talking about sulfur. Selenium reacts with shape क्या होगी? 6 bonds. What's the shape with 6 bonds?
Octahedral.
ठीक है, it's going to be octahedral. Octahedral का मतलब है there's going to be one bond उसके ऊपर होगा, one on the right, one on the left, one at the bottom, एक उसके बैक साइड पे होगा, एक उसके सामने आ रहा होगा, ठीक है। अच्छा, next is the most stable oxide of selenium is SeO2 gaseous। अब SeO2 और उसे सल्फर का पहले मेंशन किया हुआ, रिमेंबर, थिंक ऑफ Fe as sulfur, ठीक है। जब वो ये बात कह देते हैं ना कि सिमिलर केमिकल प्रॉपर्टीज as sulfur, so it's basically talking about sulfur. This is sulfur dioxide group 6 में, there's going to be one lone pair, which is why उसकी shape जो है ना that's bent, क्योंकि वो एक साइड पे ना instead of having a bond there's a lone pair. It has a total of 6 electrons. It forms a polymer as shown in the reaction. One SeO2 is replaced by 2 SeO to form a polymer. So वो double bond वाले bond यहाँ पे खत्म होते हैं and it starts connecting with the same type. The bond enthalpy of SeO is 514. Use these data to calculate the bond enthalpy in kilojoules of SeO. Remember, this is a tricky part, ठीक है? What you have to do is, the first thing is given you the enthalpy change. So what is the enthalpy change? The enthalpy change is the overall energy change when you add up the bonds broken. Delta H, what is delta H? Okay, bonds broken. And you minus the bonds formed. Achha, bonds broken is endothermic, so that is positive. And the other one is minus bonds formed, that's exothermic. ठीक है, तो इसलिए वो minus sign है. Now, how many bonds are actually getting formed? इसको तो कुछ भी नहीं हुआ. ठीक है, तो इसको तो वही रहने देते हैं. The double bond between SeO is broken, and that value is given as 514. ठीक है, so that इस वाले को तोड़ा. ठीक है, that's the bond that has been broken. तो double bond, ठीक है, that's the one that's being broken. अच्छा, इसको ब्रेक करके बनाया क्या है? उसको ब्रेक करके ना सिंगल बॉन्ड फॉर्म किया है, ठीक है? द डबल बॉन्ड हैज बीन टर्न इनटू अ सिंगल बॉन्ड, यू कैन सी ओवर हियर। सो बॉन्ड्स फॉर्म्ड वो माइनस में होगा, तो 1 SE&O single bond has been formed. And apart from that, what else has been formed? ये दो bonds ना साइड पे भी फॉर्म हुए हैं। अच्छा, ये दो bonds किसके साथ फॉर्म हुए हैं? ठीक है, that's the question. What is he forming those bonds with? Uh, so what you're going to do is कि polymer is a repeat unit, ठीक है? It keeps on repeating. तो इसको ना रिपीट करना शुरू कर दो कि इसके बाद क्या आना चाहिए था? The whole thing would be repeated. So it's going to be Se double bond O. इससे पहले क्या होना चाहिए था? इट शुड बी एन ऑक्सीजन, ठीक है? तो वो सारा, हाँ ठीक है, वो उसी तरह रिपीट करो, ठीक है? सो यू वुड नो कि इक्वेशन के अंदर उसने इन सारों का नहीं बताया हुआ था, ठीक है? जस्ट शोड कि ये वाला बॉन्ड फॉर्म हो रहा है, ये वाला बॉन्ड फॉर्म हो रहा है, ठीक है? हम इन्हीं को फिगर आउट करेंगे। सो देयर इज अनदर Se&O बॉन्ड बीइंग फॉर्म्ड ओवर हियर, तो वो एक और हो गया, ठीक है? सो I'm going to add another Se&O bond, and then there's another Se&O bond formed on the left side, वो भी negative होगा, ठीक है? Exothermic. So in total you're breaking one double bond, ठीक है? SeO&O, and you're forming 3 Se&O bonds. So enthalpy change is minus 346. SeO bond तोड़ने की energy कितनी है? That's plus 514. So you're going to break one of them, and you're going to form 3 Se&O bonds. अब इसको subject to the equation बनाओ and try and figure out what the value is. It's going to be क्या होगा? SeNO. इसको तो ले जाओ. That's so it's going to be plus 346, and I think plus 514. ठीक है, इधर आएगा, ठीक है, ये दोनों plus, and the whole thing would be divided by 3, I guess. Rida, listen carefully, ठीक है? ये मैं फिर से repeat कर रहा हूँ. Okay, look at the question. How many bonds are being broken over here? Se&O double bond is being broken, right? Because that's not existing over here. So bonds broken, that's Se and double bond O. This one. Okay, this one is broken. फिर form कौन से हो रहे हैं? You've broken this and you formed this bond over here. There's a single bond. So that's one Se&O bond. और फिर मैंने इस repeat unit को extend किया था क्योंकि उसने ना show किया हुआ था ये वाले bond और ये वाला bond. उसके आगे he didn't mention कि what was next to it. तो वो मैंने थोड़ा सा ना उसको extend कर लिया. The whole repeat unit was being repeated again, ठीक है? So that means this is again an Se&O bond, and this one is also an Se&O bond. So in total, again, if I mark them in red over here, just 1 second. There's one over here, and one over here. Rita, is this clear? ठीक है? कोई मुझे आंसर बता दे कि what's the answer for this? क्या आंसर है? किसी ने किया?
जी सर, 286.7.
So 286.7. And remember it's not minus, ठीक है? It's positive. खास तौर पे if you are careful with the signs, क्योंकि bond formation का जो sign होता है ना वो negative होता है. If you are careful with this with the signs, so the answer would come out to be, when you calculate the bond energy, it's going to come out to be positive. As the next one is SeO2 shows similar chemical properties to SO2, suggests an equation to show the reaction of SeO2 with aqueous NaOH. Now the question is about SO2. It's not about S को ना change कर दो. जब इस तरह का question है, is basically talking about SO2. It's going to react with NaOH. Now it's an acidic oxide. Okay, this one is an acidic oxide. What you should remember is whenever you try to make an equation of an acidic oxide, think of this as an acid. ये कौन सा acid बनाता है water के साथ मिलके SO2?
Sulfuric acid.
नहीं, not sulfuric acid. It forms H2SO3. Sulfurous acid. वो जो इसका दूसरा oxide होता है ना, which is SO3, that forms sulfuric acid. So when you So when you're being asked to make an equation for a non-metal oxide, think of it as an acid. अब मुझे बताओ कि H2SO3 और NaOH का reaction होगा तो कौन सी salt produce होगी? It's going to produce Na2SO3, right? Or plus H2O. ठीक है? Always remember this. अगर phosphorus oxide होता तो यहाँ पे think you should have thought of it as phosphoric acid. As in next is crude oil is a natural source of hydrocarbons that are used as fuels. Hydrocarbons with low molecular M are used as fuels in industry, in the home, and for transport. There's a high demand for. I said, what's so good with low MRs? छोटे molecules के साथ क्या issue होता है? Why are they good?
So वो जल्दी मेल्ट हो जाते हैं.
अच्छा तो ठीक है, एक तो ये कि they have low melting and boiling points. ठीक है, क्योंकि van der Waals forces कम होती हैं, ठीक है, because they're smaller, they have fewer electrons. They are less viscous. ठीक है, they don't stick, they don't have a lot of intermolecular forces. So they flow very easily, and they're very flammable because they are volatile. And since they are volatile, so they mix with oxygen very well and they burn very easily. Name the process by which long chain hydrocarbons are broken down into short. What's the name?
Cracking.
ठीक है, that is cracking. और उसके बाद है कि one reason why hydrocarbons with M are suitable as fuels, one mark ये तो more flammable, वो हम पहले ही कर चुके हैं. Next is incomplete combustion of hydrocarbons can release carbon monoxide into the atmosphere. Write an equation for the formation of carbon monoxide. The incomplete combustion of butene over here. So it's C4H8 plus oxygen plus either carbon monoxide plus water बना दो, ठीक है? And you can balance this equation. So it's 4 carbon monoxides and there are 4 H2Os. So 4 and 4, that's 8 oxygens. So 4 O2, ठीक है? अगले पे आ जाओ. Identify an analytical technique that can be used to monitor the levels of carbon monoxide in the atmosphere. Outline how this analytical technique may be used to monitor the levels of carbon monoxide. So how would you monitor the level of carbon monoxide? क्या होगा? नहीं, इसका क्या होगा? Anyone? एक सेकंड में मैसेज आया. ठीक है. There's only one analytical technique that you've actually studied, that's infrared spectroscopy. And infrared spectroscopy में होता है कि ये जो bonds होते हैं, they vibrate by absorbing frequencies from the infrared region. ठीक है, so you're going to monitor the wavelengths. You're going to monitor wavelength absorbance. अगर ये carbon triple bond oxygen की absorbance बहुत ज़्यादा है, that means there's a lot of carbon monoxide. अगर बहुत कम है, that means there's very few carbon monoxide molecule. ठीक है? Aisa, is this clear?
Yes sir. सर आपके पास इंफ्रारेड के नोट्स होंगे?
नोट्स इंफ्रारेड में कोई खास मेरे पास होंगे, मैं देख लूंगा. इंफ्रारेड में कुछ खास नहीं है. इट्स जस्ट कि if there's a random molecule over here, you don't get, मैं सारा इधर ही कर देता हूँ कि if you have this random molecule, right, तो इंफ्रारेड में होता है कि जो जितने भी बॉन्ड्स होते हैं ना, इस मॉलिक्यूल की एक पर्टिकुलर शेप होती है, बट द बॉन्ड्स दे काइंड ऑफ नॉट स्टेशनरी, दे ऑलवेज वाइब्रेटिंग. ठीक है, टू एंड फ्रो स्ट्रेच हो रहे होते हैं, एंड दे गेन एनर्जीज फ्रॉम द इंफ्रारेड स्पेक्ट्रम. तो अगर CH का बॉन्ड होगा ना, तो वो एक पर्टिकुलर फ्रीक्वेंसी एब्जॉर्ब करेगा. OH का बॉन्ड होगा, दैट वुड एब्जॉर्ब. तो वो हर फ्रीक्वेंसी एब्जॉर्ब नहीं करेगा, दे वाइब्रेट एट अ वेरी स्पेसिफिक frequency. ठीक है, they need to gain energy from a very specific frequency. An example is a swing. यानी आप एक swing लो ना, उसको आप randomly hit करना शुरू कर दो, it's not going to vibrate या move. उसको आपको एक बड़ी exact frequency के ऊपर ना उसको hit करना पड़ता है कि वो ऊपर जाए, फिर नीचे आए, फिर आप hit करते हो. ठीक है, तो atoms के bonds भी ना, they don't absorb any frequency. They absorb very specific frequencies. तो यहाँ पे if I have the data booklet with me, just one second. अच्छा यहाँ पे किधर है? Just a second, पता नहीं क्या हुआ डेटा. अच्छा. So the data booklet has table for infrared spectrum. ये ठीक है. There's a table given over here. उसके अंदर ना every bond, ये CH के bonds हैं, ठीक है. तो different frequencies जिसको wave number कहते हैं. Wave number is 1 over lambda. ठीक है. You don't need to know this. Just think of this as frequency क्योंकि 1 over lambda is basically proportional to frequency. तो different wavelengths पे different bonds vibrate करते हैं. तो infrared spectrum से ना आपको कोई ज़्यादा information नहीं मिलती. बहुत थोड़ी information मिलती है. जैसा जैसा आपका जो molecule मैंने draw किया हुआ था ना, which was where was the molecule? This one. It had a C single O bond. तो इसका मतलब है there's going to be an absorption. There's going to be an absorption at C single O किधर है? 1040, 1300 पे there's going to be a strong absorption within this range. Somewhere in this wave number. CH के bonds हैं. So there might be an absorption around these wave numbers. Lekin you're never going to get a very you're never going to identify a lot of bonds in infrared spectroscopy. You're just going to identify a very few bonds. C double bond O बहुत clearly identify होता है, ठीक है, because it has a very strong and unique absorption at 1600, which is not overlapping with any of the other bonds. OH का bond वो बहुत uniquely identify होता है, क्योंकि उसकी खासतौर पे कार्बोक्सिलिक एसिड में it has a very broad absorption. एक बहुत बड़ी एब्जॉर्प्शन आ रही होती है 25 या 3000 के अंदर, ठीक है. तो इससे ज्यादा कुछ नहीं है, ठीक है. और क्वेश्चन भी आएगा ना तो एक आध बॉन्ड की बात होगी, वो बल्कि शायद इसमें ना आ भी जाए क्वेश्चन. इज दिस क्लियर?
जी सर.
अच्छा, next is consider the equation for the complete combustion of this thing, C4H4S. So C4H4 and S क्या बनेगा, क्या क्या प्रोडक्ट्स होंगे? One is third product. बताओ, what's the third product?
SO2 or S?
अच्छा, SO, remember this कि it's always going to form SO2. SO3 form नहीं होता, ठीक है. It's going to form SO2 and you can balance this equation. SO3 form करने के लिए ना आपको काफी कुछ करना पड़ता है. You have to have a vanadium pentaoxide catalyst. You have to have 450 degree centigrade. SO3 इतने आराम से नहीं बनता. Atmosphere में बन जाता है क्योंकि you need an oxidizing agent. NO2 acts as an oxidizing agent, converts SO2 into NO2. Achha, next is a student carries out an experiment to determine the enthalpy change of combustion of this thing. What is meant by the term? What's the definition of this?
When 1 mole of a substance is completely burnt in excess oxygen.
अच्छा, पहले तो बताओगे it's exothermic होता है. Energy released, ठीक है, when 1 mole of substance completely burns in excess oxygen. और क्योंकि उसने he is not using the word standard. अगर standard use करता ना तो फिर आप कहते हैं कि measured under standard conditions. ठीक है, at the moment she's not using the word standard, तो इसलिए you don't need to write this last line. Anyways, next one. There's this water that's there's this water that's उसका mass of water in the copper container दिया हुआ है, ठीक है. So it's 200 grams. अच्छा, ये कितने initial temperature and the highest temperature reached. So tell me what is delta T over here? This is the calculator. कितना?
19 degrees.
अच्छा, ठीक है, 19 degrees. Or remember MC delta T में whether it's Kelvin or centigrade, the change is exactly the same. So you don't have to do any conversion. Water की heat capacity दी हुई है, and he's asking calculate the heat energy released by the reaction. So you're going to do MC delta T. So it's 200 grams of water. The assumption is that all of the heat energy in the reaction is absorbed by the water in the container. So it's going to be 200 grams into C क्या है 4.18 into delta T, which is 19. क्या value आई है?
1.6 into 10 raised to power 4.
अच्छा, इसके साथ साइन लगाने की जरूरत नहीं है क्योंकि उसने खुद ही कह दिया कि रिलीज्ड है, ठीक है. सो नो नीड टू ऐड द नेगेटिव साइन टू इट. वरना अगर ना लिखा होता ना तो फिर ऐड कर देना नेगेटिव एक्सोथर्मिक है, ठीक है. नाउ द स्टूडेंट यूजेस 0.63 grams in the experiment. Calculate the enthalpy change for the combustion of this. Include a sign in your answer. अब वो कह रहे हैं साइन भी लिखो, ठीक है. तो वो ये कह रहे हैं कि ये जो ऊपर वाला रिएक्शन नहीं था, ये वाला जिसके अंदर इतनी हीट एनर्जी रिलीज भी है, तो उसके अंदर 0.63 grams. पहले तो बताओ कितने मोल्स हैं ये. फाइंड द मोल्स. 0.63, ये जरा कैलकुलेट करो. एमआर क्या होगी? दैट्स 12 into 4 क्या होता है? दैट्स 48 प्लस 4 हाइड्रोजन्स भी हैं, 4 प्लस एक 32 भी बीच में ऐड कर दो तो दैट्स 84 बन रहा है. क्या बन रहा है? इट्स 0.63 डिवाइड बाय
84 1.
अच्छा, सो हाउ मेनी मोल्स डू यू हैव?
You have 7.5 in 10 raised to minus 3.
7.5 times 10 power minus 3 moles, right? अच्छा, ये जो था ना, ये इसने इतनी एनर्जी प्रोड्यूस किया 1.6 into 10 raised to power 4 और जूल्स के अंदर है, ठीक है. तो the enthalpy change of combustion is for 1 mole. तो उस हिसाब से रेशो लगाओ कि 1 मोल होता तो फिर कितनी एनर्जी प्रोड्यूस होती है. तो put that as x. क्या करना है आपने? It's going to be 1.6 times 10 power 4 divided by 7.5 times 10 power minus 3. What are we getting?
2.1 into 10 raised to power 6.
कितना? 2.1
1 into 10 raised to power 6.
जूल्स में ना, किलो जूल्स में क्या होगा?
Uh,
He's-
2.1 into 10 raised to power 3.
कितना?
2.1 into 10 raised to power 3.
Into 10 is per 3. And also, चलो ठीक है, that's fine. 2.1 into 10 is per 3. ये चेक भी कर लेते हैं कि ये सही भी निकाला है कि कहाँ पे है. This one. 2.18. इतना डिफरेंस क्यों आ रहा है? मतलब सेम ही है लेकिन इट्स 2120 आ रहा है, वहां पे 2118. बहुत ज्यादा बीच पे राउंडिंग तो नहीं की? अच्छा, ये राउंडिंग की हुई है ना 7. अच्छा, बीच में स्टेप्स में राउंडिंग ना करो. ऊपर से ये भी 84.1 था, नॉट क्योंकि रिमेंबर इस चीज का ख्याल रखना है, ठीक है. यू हैव टू बी वेरी केयरफुल विद दिस कि स्टेप्स के अंदर राउंडिंग नहीं करनी. जितने भी स्टेप्स होंगे कैलकुलेटर के ऊपर कोई राउंडिंग ना करो. जितना भी आंसर आ रहा है ना उसको, जिस तरह उसने ये पूरा एग्जैक्टली आया हुआ है 491082.045, ठीक है. मेरे ख्याल से आर एरर स्टार्टेड
ऊपर
एट
भी
दिस.
किया ना,
हाँ,
तो ऊपर भी किया है वो 15884 आ रहा था.
हाँ.
तो ये फोर्थ दोबारा एक्सप्लेन कर.
कौन सा?
फोर्थ पार्ट
नहीं, पूरा
नहीं, बी का फोर्थ पार्ट एक्सप्लेन कर दे, मेरा नेट स्लो हो गया था.
अच्छा, वो मैं बता देता हूँ कि वो कह रहा था कि ये जो इब्रार, इसमें क्यों हमारा वो आया है कि अच्छा, वो यहाँ पे नहीं, इसमें हमारे पास होल नंबर आ रहा था कि वो आ रहा था
होल
राउंडेड?
नंबर.
एग्जैक्टली होल
होल
नंबर आ
ये
रहा
तो मैंने राउंडेड किया. The exact value was 1.58.
ठीक है. 1.58 लेते हैं और स्पेसिफिकली 3 सिग्निफिकेंट फिगर्स क्योंकि ही वाज यूजिंग 3 सिग्निफिकेंट फिगर्स. अच्छा, एनीवेज
1.5888.
ठीक है, तो 1.9 हो जाता, ठीक है. अच्छा, दिस वन आइजा जस्ट एक्सप्लेनिंग दिस अगेन. व्हाट यू हैव इज कि ये एनर्जी जो उसने कैलकुलेट की थी ना, उसने कहा था कि इतना ये जो भी C4H4S 0.63 ग्राम्स बर्न हुआ था, ठीक है. तो उससे हमने मोल्स निकाल लिए कि जी इतने मोल्स बर्न किया था तो इतनी एनर्जी रिलीज हुई थी। तो उससे क्वेश्चन में कहा था कि फाइंड द एंथैल्पी चेंज ऑफ कंबशन। द एंथैल्पी चेंज ऑफ कंबशन इज ऑलवेज फॉर 1 मोल। तो आप फिर रेशो लगाओगे कि अच्छा इतने के लिए इतनी एनर्जी रिलीज हुई है तो 1 मोल के लिए फिर कितनी एनर्जी रिलीज होगी, तो उससे फिर आपने फिगर आउट की। ठीक है। अच्छा लेकिन लेकिन जस्ट बी वेरी केयरफुल कि एक तो वो पीरियोडिक टेबल का मसला है कि पीरियोडिक टेबल में जो आपका जो पीरियोडिक टेबल है उसके अंदर यू हैव टू बी वेरी केयरफुल, क्योंकि आदत बनी होती है ओ लेवल से कि इसके अंदर हमने हमने इसमें कौन सा गलत लिया था, C4H4 और S था ना, तो अब वो ओ लेवल से आदत पड़ी हुई है कि S32 है तो हमने S32 ले लिया था। ठीक है। लेकिन ऑलवेज चेक द प्योर टेबल। ये प्योर टेबल में आपकी एक्यूरेसी काफी ज्यादा है, उसकी जो रिलेटिव एटॉमिक मास है दैट्स 32.1 व्हिच इज गिवन ओवर हियर। ठीक है, इस जगह 32.1 गिवन है। बिकॉज ऑफ दैट यू माइट लूज 1 मार्क ऑफ एक्यूरेसी कि अगर आपका आंसर जो है वो वेरी करेगा, तो इसलिए वो 2118 आ रहा था which and the true answer was actually 2120. अच्छा नेक्स्ट इज रिदा, क्लियर है सारा? अच्छा next one is you have to give the name of this molecule, ये वाला। Okay, there's C and there's an aldehyde CHO, और फिर इस C के साथ ना there's 3 CH3s, so there's a CH3, there's another CH3 and there's a third CH3। अब ये बताओ कि ये क्या चीज है? What is the name of this one?
Group 2 dimethyl aldehyde.
नहीं, पहले तो मेन चेन के कितने कार्बन एटम्स है? दैट्स 3, राइट? तो मेन जो मॉलिक्यूल होगा दैट्स गोइंग टू बी prop, right? And what would you call this?
It's an aldehyde, so
So it's an aldehyde, तो propanol होगा ना, right? Because it's an aldehyde।
2-dimethyl propanol।
ठीक है, तो 2 मिथाइल के ग्रुप्स हैं, so that's 2 और दोनों सेकंड पोजीशन पे हैं, so it's 2 dimethyl, or you can say 2 methyl। ठीक है। अच्छा, so 2 dimethyl propanol, state the hybridization of the carbon atom labeled within with this, ये जो star है, when carbon is bonded to 3 atoms, what's the hybridization?
sp2।
ठीक है, that's sp2। उसकी शक्ल क्या होती है? It looks like this, that it has 3 bonds and the 4th electron is involved in pi bonding। ठीक है, it has 3 sp2 hybrid orbitals, so that's 3 electrons getting pulled in different directions by 3 atoms, and the 4th electron is involved in pi bonding। And the next one, there's a bunch of reactions going on. Reaction number 1 is oxidation। That's clearly an oxidation क्योंकि an aldehyde changes into a carboxylic acid। तो मुझे तो how do aldehydes change into carboxylic acids?
Oxidation।
ठीक है, so it's oxidation। नहीं, वो तो ठीक है, वो ऑक्सीडेशन तो उसने किया हुआ है, वो रिएजेंट बताओ कि क्या है। ठीक है, so that's you can use KMnO4, yes। सारे बताओ कि how do you oxidize aldehydes? KMnO4, K2Cr2O7, and he's also asking for the conditions। So there's
Self-flux।
ठीक है, there's going to be reflux। Apart from these 2 oxidizing agents, what else can be used?
HNO।
The Tollens reagent is used। ठीक है, and there's another one, Felling reagent plus heat। ठीक है, 3 reagents are used that can oxidize an aldehyde to a carboxylic acid। अच्छा, उसके बाद is a carboxylic acid is a solid at room temperature, this one is an ester, is an isomer, It is a liquid at room temperature. Explain the difference in the physical state in with reference to the intermolecular forces. The first thing, this is the carboxylic acid. What's the intermolecular force in carboxylic acid?
Hydrogen.
Okay, so that's A. The first mark, 3 marks. A is it has hydrogen bonds. Okay, that gives you 1 mark. What is this molecule? This molecule is an ester. An ester is a carbon chain with a double bond O and O in the middle, and followed by another carbon chain. What intermolecular forces would B have?
Van der Waals was involved.
Nee, van der Waals, but is it a polar molecule?
Yes. The permanent dipole.
Okay, so it's the oxygen is partial negative, the carbon is partial positive. So B has permanent dipoles. I said both of them have van der Waals forces. Okay, van der Waals forces are always there, but since the sizes are exactly the same, so the van der Waals forces is not a factor in determining which one has stronger van der Waals forces or weaker van der Waals forces. Now, now the other thing is, what's the third mark for? क्या होगा? What's the third mark for?
Physical state.
नहीं, third mark ये होगा कि हाइड्रोजन बॉन्ड उस फिजिकल स्टेट तो सब बताया हुआ है कि A is a solid, right? तो तीसरा मार्क जो होगा that's for कि हाइड्रोजन बॉन्डिंग is stronger than permanent dipoles. ठीक है, that's stronger than permanent dipoles. खैर इतना अपनी write proper statements. ठीक है, that's going to be your third mark. And let me check the distribution of the marks for this one. ठीक है, hydrogen bonding, permanent dipole, and hydrogen bonding is stronger. ठीक है, that's the third mark for. अच्छा, next is what's next? Next is give the balance equation for the reaction of an aldehyde with NaBH4 to form S. What happens if you reduce? This is a reducing agent. What happens if you reduce an aldehyde?
Alcohols are formed.
ठीक है, तो ये जो CHO वाला part है ना, that would change into an alcohol, so it would become CH3 or with 3 CH3 branches हैं, and then you have the C would change into CH2OH. It would turn into an alcohol, a primary alcohol. Now, as I said, it would turn into a primary alcohol.
दूसरा
What do
कार्बन
you
नहीं
do
होगा
with? हाँ,
दूसरा कार्बन नहीं होगा यहाँ पे CH3
नहीं वही कार्बन जो होगा ना, that would change into ये ना कि it's RC double bond O and H, and that changes into RC. उसके साथ ना 2 H लग जाएंगे, and it would turn into an OH. The CHO turns into CH2OH. Is this clear?
यहाँ पे तो we have two
क्या चीज?
यहाँ पे तो we have two carbon, right?
हाँ, I didn't see that. ठीक है, there's put 1 carbon over here. ठीक है, I missed that carbon. The one with the CH3s. ठीक है, I missed that carbon. ठीक है, so add that. अच्छा, okay, you had to write a balance equation, and the reducing agent had to be represented by an H. So add that H. So how many H's are getting added? That's how many H's getting added. That's like the O is still there.
One.
Nee, not one. There are 2 H's getting added. ठीक है, यहाँ पे there was only 1 H,
Yes.
and now there are 3 H's. ठीक है, so there are 2 H's that are getting added to this. So that is reduction that's happening, that's taking place. अच्छा, next one, draw the structure of, इसको मैं clear कर दूं. अच्छा, draw the structure of the organic molecule T that reacts with this thing in reaction 2 to form U. Suggest the catalyst for reaction 2. So draw the structure of the organic molecule with A, which is this one, in reaction 2. ये क्या कह रहा है? Draw the structure of the organic molecule that reacts with A. What is A? A जाके find where did A go? 1 second, let me. So what is A? A is a carboxylic acid. And where did U come from? So this is U. So U is an ester. So he's talking about this reaction over here. So we're talking about this reaction. So a carboxylic acid, I mean, this is the carboxylic acid with the 3 carbon chains, and this is your carboxylic acid, and it is forming an ester. Break the ester, that's your alcohol. Okay, so it's going to be OH with these 2 branches. So this is the alcohol. And this was your original carboxylic acid, the 3 carbon chains with the C and the serial bond O and OH. Okay, so they're forming an ester. So the molecule that's reacting is an alcohol. And I think he was talking about naming this. So you have to give the name. The molecule looked like this. Okay, I don't think he was asking for the name, he was asking for the structure. So this is the molecule. And then what's the catalyst for esterification? And in this molecule, if somebody had asked for the name of this molecule is propan-2-ol. It's 3 carbon atoms. So that's 3 carbon atoms in a line. So that's prop with the OH on the middle carbon atom. So that's propan-2-ol. Okay, so it's propan-2-ol. As a catalyst, what's the catalyst for esterification? That's H2SO4, and it's concentrated H2SO4.
Could it be Al2O3?
Not for esterification. Al2O3 is for dehydration or for cracking, not for esterification. Okay, that just concentrates H2SO4. So next is what's next? So X, Y, and Z are all isomers of this aldehyde. So this is a question on isomers. These isomers. So the question is a summary of some of the reactions and properties of X, Y, and Z shown in the table. Those are observation दी हुई है, ठीक है? It's Isaac, this is about infrared spectroscopy. So there's an absorption that's happening at the 1715 mark. तो जल्दी से देखो what's 1715. ये मैंने कहा था कि this was very easy to identify. Where's the infrared spectrum? Just a second. 1700, 1600. That's very easy to identify. ठीक है, that's this one. ठीक है,
Ester?
not ester. It's the C double bond O group.
Oh,
ठीक है?
okay.
Around the 1700 mark. It could be an ester, it could be a carboxylic acid, it could be a ketone, aldehyde, amides. उनमें से कोई भी हो सकता है, ठीक है? तो going back, कहाँ पे ये? So this indicates that there is a serial bond O. We don't know which one at the moment. लेकिन the observation with Fellings is there's no reaction. तो इसका मतलब है it has no reaction. That means it's a ketone. Ketones don't get oxidized. ठीक है, it's a ketone. That's the first one. So it's a ketone. Now, how do you make a kitne carbon atoms? That's 3 in the carbon chains. That's 5 total. Okay, so I mean, you could come up with a lot of ketones. Okay, so it's a ketone because it has a serial bond O. So you can make a ketone. But there could be other ketones that could be possible as well. You could have 4 carbon atoms. Ye confirm kar lo, does it have 5 carbon atoms? It has 5 carbon atoms. As anyways, it could be this ketone as well. Now, apart from that, I don't think is there any other ketone possible apart from these? There's that's not possible. If I bring the C over here, that would turn into an aldehyde. So probably these 2 ketones. Now, since it's a ketone, it's going to give a 2,4-DNPH test. 2,4-DNPH, remember, is a positive test for both aldehydes and ketones. It gives an orange precipitate. So in this case, it is going to be an orange precipitate because it's a It's a ketone. अच्छा, next one. Felling के साथ red precipitate बन रहा है. That means it is getting oxidized. That means it's an aldehyde, right? तो ये वाला जो है ये तो aldehyde है. And so it's an aldehyde. Think of an aldehyde. मेरे ख्याल से आगे जाके और भी information दी होगी. This one is X. It's either one of these two. This one is an aldehyde. So how many aldehydes? One of them is already given, so I can have an aldehyde with 5 carbon atoms in a line, and I can have an aldehyde at the end. Okay? Or I could have 4 carbon atoms in a line. The double bond O would still be at the end, and there could be a carbon over here, or there could be a third one as well. That I could have 4 carbon atoms in a line. This one could be an aldehyde, and a carbon could be over here. And there could be actually a fourth one as well. Okay, I could have double bond over here at the end, and there could be carbon chains over here. So it could be any of these aldehydes, and this one would give an orange precipitate as well. अच्छा, अगला
So Felling solutions oxidation के लिए use होता है.
हाँ, वो भी हमने किया था ना कि पिछले पार्ट में कि
ठीक है.
मतलब कहीं तो हमने किया था अभी. Felling tolerance और
So याद आ गया.
ठीक है.
सही है.
अच्छा, identify a functional group present in Y that causes the recorded observation with Fellings. So that's Y के अंदर. So that's aldehyde. ठीक है, that's the functional group. अब वो कह रहे हैं कि Y has a chiral center, and यहाँ से हमें पता लगेगा कौन सा वाला. ऊपर हमने काफी options किए थे. So Y has a chiral center, and it forms optical isomers. State what is meant by the chiral center. So when carbon is
Bonded with 4 different atoms.
groups, ठीक है. अच्छा, it's bonded to 4 different groups and forms 2 non-superimposable mirror images. ठीक है, let me just confirm. नहीं, उसने सिर्फ यहीं तक दिया. When carbon is bonded to 4 different atoms. You can write the rest of the story as well. अच्छा, draw the optical isomers of Y. पहले तो identify करो Y क्या है. अब Y was, ये सारे मैंने Y draw किए थे. Aldehydes. ठीक है, 5 कार्बन आटम वाले ना aldehydes. It could either be this one, this one, this one, or this one. Now tell me which one is optical out of all these 4.
Sir double bond में होना चाहिए फिर तो.
नहीं, optical होता है जब वो carbon is bonded to force. ये वाला carbon जो है ना, this one, इसके साथ एक H होगा. This is the one that's this would be CH3. This would be CH2 and CH3.
Sir अगर वो optical isomer बना रहे तो double bond होना नहीं चाहिए.
नहीं, वो cis geometric में होता था, cis trans में double bond.
मतलब isn't this मतलब this atom also chiral?
नहीं, this is not chiral because this one is bonded to 2 H's. The one with the double bond cannot be a chiral, and this one is bonded to 2 CH3s.
अच्छा.
ठीक है, so this is not chiral. This is also not chiral because CH2, 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 CH3. This is also not chiral. ठीक है, तो it's this one. तो ठीक है, ये complete हुआ कि नहीं हुआ? So we'll continue from here tomorrow. ठीक है, अजान शुरू होगी. Let's continue tomorrow.
अल्लाह हाफिज़.
Okay, take care.